A child of mass 28 kg goes down a slide starting from rest. The total drop in height of the slide is 4.5 meter. If the slide is smooth, find the speed of the child at the bottom of the slide. B. In fact, the slide is rough and the child reaches the bottom traveling at a speed of 5 meter per second. Find the work done against friction and the average friction force given that the total length of the slide is 12 meters. Okay, I would always advise students to draw a free body diagram or just a sketch. It doesn't have to be accurate, just for your understanding. Okay, let's say a child is here and then it slides down. Okay, and it's given that the height is 4.5 meter. Okay, you know what a slide looks like, and then the weight or the mass of the child is 28 kg. The total drop in height, okay, that's done. If the slide is smooth, find the speed of the child at the bottom of the slide. Okay, to find this, whenever a mass is positioned at a certain height, okay, or an object is positioned at a certain height, then the moment when it comes to height, okay, we have to know the one energy that is always thought when it goes up at a certain height is potential energy. So find what is PE over here. Okay, potential energy, PE equals to mgh. Okay, potential energy, so m here is 28 kg multiplied by 10 and multiplied by the height, which is 4.5 meter, and use your calculator to find your answer. And this is 28 times 10, and it's 1260 kg. And to find the speed or at the bottom of the slide is, okay, V or Ke equals to half mv square. Okay, why it's Ke, which is kinetic energy? Why? Because when it goes down, there's movement. Anything when there's a motion or movement, the energy that is associated with it is kinetic energy. Okay, because kinetic energy doesn't exist without motion. Okay, so velocity V is where the velocity is. Velocity meaning there's a movement, okay, displacement over time. So therefore Ke equals to half mv square. So half times by m, which is 28 kg, and then times by v square, and this is equal to, okay, 1260 joule. Okay, 1260 joule. Okay, 1260 joule. Okay, why? Because we know the conservation of energy, of the principle of energy is energy, you can't destroy it. Okay, you can't create it. It can only change position from, or change form from one to the other. Okay, from energy potential it can go to kinetic, and from kinetic it can go to potential. Okay, so in this case, when at a certain height, or in this case is 4.5, we have potential energy. As it goes down, the height decreases, so potential energy start changing form to kinetic energy. So as it goes down lower and lower, when the height becomes lower and lower, it changes form until it becomes completely kinetic energy at the bottom when the height is 0. So from there, 1260 equals to half times by 28 times by v square. So this is 14 times by v square equals to 1260. So v square equals to 1260 divided by 14, and from there v equals to square root of 1260, which is 90, and the answer is 9.49 meter per second. Okay, for part B, in fact the slide is rough and the child reaches the bottom traveling at a speed of 5 meter per second. Okay, so it doesn't for the question A it comes at 9.49 because it's smooth, but now it's rough, so there's a decrease in velocity or the speed. Okay, 5 from 9 it becomes 5 meter per second. Okay, no problem. So loss of PE Potential energy is basically the gain in kinetic energy and the resistance from the friction. Okay, remember the loss of potential energy is equal to the gain in kinetic energy plus the resistance. We don't have to do that for the first one because it's a smooth plane, okay, or it's a smooth surface, okay. But for the second one, it's friction, okay. It has friction. If there's friction, then there's resistance, so you need to consider that. So loss in PE, so from 1260 it becomes E equals to kinetic plus equals to kinetic energy plus the resistance, okay. So, and what is the kinetic energy? Half times by m times by v square. V here is 5 meter per second, so 5 square plus the resistance, okay. I'll just write it as r, okay. So this should be 1260 times by half times by 28 times by 25 plus r, and this is 14 times by 25, 1260 plus r. So r therefore is 1260 minus 14 times by 25, and the answer is 910, okay. 910, okay. So okay, 910 is in joule, okay. I think I need to add this here, okay. Resistance meaning work done due to resistance, okay. It's basically the work done due to resistance, 910 joule. So once we have that, then the next part is we have to find, the question here require us to find, given the total, find the work done against friction, okay. Work done against friction. So work done against friction, which is 910 joule, and find the average frictional friction force as well. So if it's force, then we are talking about Newton, okay. This is in joule, that's work done, okay. That's an energy change in energy is basically work done, okay. So but in for friction it's about Newton, so I have to find what is the Newton, okay, or the resistance is. So now W work done equals to F times by D, okay. So W over here is 910 joule, okay. This R, okay, in this case R here is, we are talking about the work done due to resistance, okay. Work done, okay. WD, I'll just change this to WD so that little w, oops, little WD, okay. So WDR equals to 1260, okay, minus that, which is 910 joules. So the work done due to resistance is 910. So from there, find out what is the force, frictional force, that's which acted to give this 910. So frictional force I don't know, but I know the distance given as 12 meters, okay. So times by 12, so F equals to 910 over 12, and the answer is 75.8 Newton, 75.8 Newton.